Hi ladies, welcome to the first flipped lesson for trigonometry, and it's going to be on arc length. So there's a new formula that you need to learn, and that's L equals R theta. So with this formula you just have to remember that theta is in radians. So this is the proof now of where that formula comes from. So you know that the ratio of an arc length to the circumference of a circle is equal to the ratio of the angle that it makes at the centre to the angle of the whole revolution. Now, if you make that angle in the whole revolution in radians, that's going to be 2 pi radians. Okay, and now you know the formula for the circumference of a circle is 2 pi r. And then just multiplying both sides of this equation by 2 pi r and 2 pi's cancel, you're just left with L equals R theta. So that's one of the formulas you need to remember. Okay, so let's look at this first example. Find the exact arc length of a circle if the radius is 2 centimetres and the angle subtended is pi on 6. So, using our formula, L equals R theta, our radius is 2, and our angle theta is pi on 6, that's already in radians. And because it says here, find the exact arc length, and you know that you want to leave your answer in radians. So our answer is going to be, you know you want to leave your answer in terms of pi. So your answer is going to be pi on 3. And because the radius was in centimetres, it means our arc length will also be in centimetres. So there's our exact arc length. Okay, the next example says find the arc length of a circle if the radius is 5 centimetres and the angle subtended is 33 degrees and 12 minutes. So now, using our formula again, L equals R theta, the only thing we have to do different to the first example is make sure we change the angle from degrees to radians. So you might remember that to change from degrees to radians, we multiply that angle by pi on 180. And then because it doesn't say find the exact arc length, you can just type this into your calculator. So 5 times 33 degrees, 12 minutes, times pi on 180. And my answer is 2.8972. So let's round that off to 2.9 centimetres, to 1 dp, 1 decimal place. Okay, the next question says, in a circle of radius 8 centimetres, an arc of length 9 centimetres subtends an angle theta at the centre of the circle. Find theta to the nearest degree. So what that is saying is our radius is 8 centimetres, our arc length is 9 centimetres, and we want to find this angle in the centre there, that angle there, theta. So using our formula, L equals R theta, you've got the arc length, which is 9, you've got the radius, which is 8, and we want to find theta to the nearest degree. So using this formula will give us theta in radians. So theta is going to be 9 on 8 radians. And to change radians to degrees, we want to times by 180 on pi. So putting that in your calculator, you'll get 9 on 8 times 180 on pi. And I'm getting 64 degrees to the nearest degree, 64.45, so that's 64 to the nearest degree. Alright, the last example is getting a little bit trickier now. So this is question 10 from your textbook. A sector of a circle with radius 5 centimetres. So let's draw a picture here for this one. 5 centimetres. And an angle of pi on 3. Pi on 3. Is cut at the centre is cut out of cardboard. It is then curved around to form a cone. So this little bit here So it's going to be make this cone. Okay. So this little sector here is being cut out to make this cone. Find its exact surface area and volume. So we want to find the surface area and volume of this cone. Now we've got surface area of a cone. Pi rs is the area of the curved surface. Plus we also have to add on there the area of the base, which is pi r squared because it's a circle there. And there's the formula for volume of a cone, 1/3 pi r squared h. Now this radius that they're talking about here is the radius there of the base of that circle. So what information can we use from this circle, or this sector here, to help us find the surface area and volume of this cone? Well, what we can do using the arc length formula is find that arc length there that I've just coloured in black, and then remember that was curled around, so that arc length there then becomes the circumference of the base of the circle. And we can use then we can, if we've got the circumference, then we can find the radius of that circle, and then we can also, what other information can we use? Well, see the radius there of our sector, that becomes this part here of the cone. So if the radius was 5, you can see that the slant edge, which is this S in this formula, is 5. So let's first find this arc length. L equals r theta, where r, the radius, is 5, and theta is pi on 3. So times by pi on 3. So it's just the arc length is 5 pi on 3 centimetres, because the radius was in centimetres. So that then becomes, remember, the circumference of this circle here. So the circumference of the circle, 2 pi r, equals this arc length over here, which was 5 pi on 3, where r is the radius there of that circle there. So simplifying that, the pi's will cancel each other out, and just dividing both sides by 2, you get r equals 5 on 6 centimetres. Okay, so now we can use that and the slant height to find the surface area of the cone and the volume of the cone. So, surface area, it's going to be pi rs plus pi r squared. So we've got pi times 5 on 6. Ooh. Let me get rid of that big arrow. Maybe, maybe not. So surface area is pi times 5 on 6 times s, which is 5, plus pi r squared, pi times the radius, which is 5 on 6 squared. Radius squared becomes 25 on 36. So this really becomes 25 pi on 6 plus 25 pi on 36, and 25 pi on 6 plus 25 pi on 36. So common denominator will be, lost common denominator will be 36, and you've got to multiply 25 by 6, which is 150, plus 25 is 175. So the answer for the surface area is 175 pi on 36. And then our volume of a cone is 1/3 pi r squared h. Remember, if you've got a cone and a cylinder of the same radius and height, 3 of those cones will have the same volume as that cylinder. So we've got 1/3 times pi times the radius squared. Oh, let's just square that. 5 on 6 squared times the height. Ooh, the height. How are we going to find the height? We need some more colours. So the height that I'm talking about is... Oh, there's some more colours. Cool. Okay. That height there. Now we can use Pythagoras theorem because it's a right cone, so there's a right angle there. So h is going to be square root of 5 squared minus the radius squared. What's the radius squared? 25 on 36. Oh, can I fit it in? Yes. So what does that all equal? Now remember the question said find the exact surface area and volume. So, how did I get those colours? I don't know. Let's keep writing in purple. Okay, so we got 1/3 times pi. Oh, let me just erase that bit. We can probably simplify this bit first. So we've got 25, 36 times 3. Oops. 25 on 3 times 36. That is 25 and 108. So we've got 25 pi on 108 times, and then let's simplify this, square root, well, 5 squared minus 25 on 36. It's going to be 875 on 36. So the square root of that, and if you just press the square root of that on your calculator, it's not going to give you an exact answer. So let's see what that can be. Well, we can square root the denominator, because the square root of 36 is 6. So how can we simplify the square root of 875? So let's see what square numbers are a factor of 875. So can't divide by 36, can't divide by 49. How about... Nope. 875 divided by 25 is 35, so we can simplify that by saying it is square root of 25 is 5, so that's 5 root 35 on 6. And now let's simplify that whole thing. So 25 times 5 over 108 times 6. And we get 125 pi root 35 all over 648. Okay. And then that will be centimetres cubed. Oh, and the surface area would have been centimetres squared. Okay, thanks.